In this video, I'm going to look at areas of regions between curves. Now, suppose my goal is to find the area between these two curves. That will be equal to the area under this curve um, minus the area under this curve. So the area under g of x minus the area under f of x will give me the area between the curves. So the area between the curves will be equal to the area under y is equals to g of x minus the area under y is equals to f of x. Good. So how can we represent this using definite integrals? So we are saying that A, the area A, will be equal to integral from A to B of g of x with respect to x minus the area from A to B of f of x with respect to x. We can write this as a single expression. So the area from A to B of g of x minus f of x and with respect to x. Okay, so that's how you find the area between two curves. I'll explain this using an example. So find the area enclosed by the graphs of the curves. We have two cubic functions here. Now, before we start calculating, because we want to find the area enclosed by this, let's start by finding the points of intersection of these two curves. So at the points of intersection of these two curves, we'll have a half x cubed plus 2x squared plus 2x minus a half being equal to, so the first function is equal to the second function. Remember, basically means f of x is equals to g of x at the points of intersection, and that's basically what I'm doing here. So I'll have negative a half plus 3x plus 2x squared minus a half x cubed. I can go ahead and cancel a few things. Cancel that, half gone, a half gone. So if you simplify this, you will end up with x cubed minus x is equals to 0. So x into x squared minus 1 is equals to 0, or x into x plus 1, x minus 1 is equals to 0. So we are saying that at the points of intersection, we have 3 points of intersection at x is equals to 0, x is equals to 1, and x is equals to negative 1. So we'll use this to sketch later on. Something else that we can use to sketch is by inspecting the behavior of these cubic functions. So inspect and behavior of these cubic functions. Okay, what I mean by this is if you have a cubic function with a positive leading coefficient, you know where it starts and you know where it ends. If you have a cubic function with a negative leading coefficient. You know where it starts. So I'll just draw a sketch to give us an idea of what's going on here. This sketch is just to give us an idea of these cubic functions. Does not mean that I'll draw exactly how they look like. So we know that if a cubic function has a positive leading coefficient, like for example f of x, okay, f of x has a positive leading coefficient, this one here, the one on the left, with a positive leading coefficient, it means that it starts down and goes up. So that means it will start down and then go up. If for the second one it has a negative leading coefficient, it means that it will start up and then go down. So what I mean here is this. I don't have to draw the axis, I just want these graphs, so I'll just go straight away and draw how they look like. So f of x, which has a positive leading coefficient, it looks something like that. So this will be y is equals to f of x. Now the other one, g of x, negative leading coefficient, it will be something like that. Okay, y is equals to g of x. So like I said, f of x has a positive leading coefficient. Okay, this is what we mean by the leading coefficient here. So it's positive means it will shape look like that, and the other one will look like that. Of course, you can remember this from your cubic functions when you learn functions. Anyway, let's carry on. So we want to find the area enclosed by the two curves. So what we want is basically these areas. I'll call this A, I'll call this B. We know where these curves intersect. Okay. Now this is when x is equals to -1. This is when x is equals to 0, and this is when x is equals to 1. We have already worked this out from our answers here. I'm not just creating things from here. Okay, these are the points where the curves are intersecting. Now, one more thing that you need to know is this. Between x is equals to -1 and x is equals to 0, we can see that f of x is greater than g of x, and between here, g of x is greater than f of x. Okay, so what we'll do is we'll use that to know how to integrate this, especially when you're working out the area of A, we'll know what to do. When you're working out the area of B, we'll know what to do. And that's what I'm going to do next. So work out the area of A separately, and then work out the area of B separately. So let's start with the area of A. Area of A will be integral 0 to -1 f of x minus g of x this will be equal to um, half x cubed plus 2x squared plus 2x minus a half. That's a function that we have up there. Minus negative a half plus 3x plus 2x squared minus a half x cubed. Now I'll just add one more bracket. Now just remember, this is f of x and this is g of x from the question. If you simplify that, you'll end up with x cubed minus x with respect to x, which will be equal to x to the power 4 over 4 minus x squared over 2, 0, negative 1, which will be 0 minus a quarter minus a half. If you plug in those limits, which will be a quarter. Good. Area of P will be the integral from 0 to 1. These are the new limits. G of x minus f of x, which will be integral 0 to 1 negative x cubed. What I've done here is, this is f of x minus g of x, but here what we have is, g of x minus f of x. So that's just the same thing but reversed. So that's why I have a negative. And this will be equal to the integral 1, 0, x minus x cubed dx. If you finish that off, you'll end up with x squared over 2 minus x to the power 4 over 4, 1, 0, which will be equal to a half minus a quarter, minus 0, which will just be a quarter. So total area will be a quarter plus a quarter, which is a half. So this is the process of how to work out this question. So the first step is sketching it, visualizing how it looks like, finding the x-intercepts, deciding which function is above the other one, and then using that idea to know how to work out the area of A and the area of B. Okay, the next thing I want to show you is how you can use your calculator to work out this. So if you want to use your calculator, you can actually work out the area of these two functions, the area between these two functions, straight away from your calculator. I'll show you the way I did it. So let me start by plugging in f of x in y1. So let's go to y1, plug in f of x. So that will be 0.5 x to the power 3 plus 2x squared plus 2x minus 0.5. And then here I'll have negative 0.5 plus 3x plus 2x squared minus 0.5 x cubed. So if I want to find the area between these two curves, using my calculator, I'm going to use this formula. So area will be equal to integral. Now what you can do is pick the lowest limit of the three limits. So the lowest is -1 here, and the highest is 1. Those are the ones that I'll use. So I'll ignore the middle one. Okay, the lowest and the highest. So the lowest is -1. The highest is 1. And then absolute value of f of x minus g of x. Dx, you should be able to get the answer. Or alternatively, you can do integral 1, -1, doesn't matter, absolute value of g of x minus f of x. Okay, what I'm saying here is the order doesn't matter which function comes first. Dx, and then we should be able to get the same answer. So let's check if this is possible. So start here. So quit alpha window. Number 4, lowest limit is -1. Okay, what did I plug in? And then 1, absolute value. So I want to plug in first function. So go to variables and then select y1 minus, again, I'm going to select y2 because that's what I'm plugging in the functions. And then with respect to x, and then you should be able to get a half. Remember, we had a half as our answer. Okay, so that makes sense, a half. Let's try and change the order here, see if we'll end up with the same thing. So alpha window number 4. Actually, I don't have to do it again. So if I just select this and then change the order here, so start with y2 minus y1. I still end up with the same answer. So the order doesn't matter. Whichever way you do it, you'll end up with the same answer. And you know how to do it. Good.